초콜릿은 달콤해 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 오렌지는 상큼해 상큼해 상큼해.
Right triangle. Brief history. The Babylonians could measure angles and are believed to have invented the division of the circle into 360 degrees. However, it was the Greeks who are seen as the original pioneers of trigonometry. A Greek mathematician, Euclid, who lived around 300 before Christ, was an important figure in geometry and trigonometry. He is most renowned for Euclid's Elements, a very careful study in proving more complex geometric properties from simpler principles. Although there is some doubt about the originality of the concepts contained within Elements, they are influential in how we think about proofs in geometry today. Indeed, it has been said that the Elements have exercised an influence upon the human mind greater than that of any other work except the Bible. First tables of sines or cosines. In the 2nd century before Christ, a Greek mathematician, Hipparchus, is thought to have been the first person to produce a table for solving a triangle's lengths and angles. The Pythagorean theorem. In a right triangle, the square of the hypotenuse is equal to the sum of the squares of the other two sides. The Pythagorean theorem is named after the Greek mathematician Pythagoras, who by tradition is credited with its discovery and proof, although it is often argued that knowledge of that theorem predates him. There is much evidence that Babylonian mathematicians understood the formula. 6. Trigonometric function. The earliest use of sine appears in the Salva Sutras written in ancient India from the 18th century BC to the 6th century BC. Trigonometric functions were later studied by Hipparchus of Nicaea, Ptolemy, Aryabhata, Varahamihira, Brahmagupta, Muhammad ibn Musa, Al-Khwarizmi, Abul Wafa, Omar Khayyam, Bhaskara II, Nasr al-Din Tusi, Ghiyath al-Kashi, 4th century, Ulugh Beg, 14th century as well, Regiomontanus, 1464, Wittikos and Wittikos student Valentin Otto Madhava made early strides in the analysis of trigonometric functions in terms of infinite series. Leonhard Euler's introduction in Analysis Infinitorum 1748 was mostly responsible for establishing the analytic treatment of trigonometric functions in Europe, also defining them as infinite series and presenting Euler's formula as well as the near-modern abbreviations sine, cos, tan, cot, sec, and cosec. The notion that there should be some standard correspondence between the length of the sides of a triangle and the angles of the triangle comes as soon as one recognizes that similar triangles maintain the same ratios between their sides. That is, for any similar triangle, the ratio of the hypotenuse, for example, and another of the side remains the same. If the hypotenuse is twice as long, so are the side. It is just these ratios that the trig functions express. Right triangle trigonometry definitions. All triangles are taken to exist in the Euclidean plane so that the inside angles of each triangle sum to pi radians or 180 degrees. Therefore, for a right triangle, the two non-right angles are between 0 and pi over 2 radians. Solving right triangle. We begin our investigation of the trigonometric functions using right triangles. Since the two acute angles in a right triangle are restricted to degree measures between 0 degrees and 90 degrees, we cover only those angles here. In this triangle side, A is an opposite angle A and side B is adjacent angle A. Side C is the hypotenuse. 6 possible ratios can be formed by selecting 2 of the 3 sides of a right triangle and forming a fraction made from the lengths of those 2 sides. 2 triangles are similar if the ratios of corresponding sides in the 2 triangles are equal. This means that the 2 have the same shape or one is a scaled version of the other. Similar triangles contain the same angles although their side lengths may differ. 6 trigonometric ratios. Name, side of A, ratio, opposite over hypotenuse, notion, sine, quantity of A over C is equal A over C. Cosine of A, ratio adjacent over hypotenuse, cos quantity of A is equal B over C. Tangent of A, opposite over adjacent, tan quantity of A is equal A over B. Secant of A, hypotenuse over adjacent, sec quantity of A is equal C over B. Cosecant of A, hypotenuse over opposite, notion CSC quantity of A is equal C over A. Cotangent of A, adjacent over opposite, cot quantity of A is equal B over A. That's all. Thank you.